Testing. You can hear me? Good. Good morning. My name is Gary Russell. For those of you who haven't been to any of my earlier talks, I've been with VMware for about 3 years now, and I've been a committer on Spring Integration for most of that time. I started out teaching and doing consulting engagements, mainly with Spring Integration, a little bit of Spring Batch, and since the beginning of this year I'm now full-time engineering on Spring Integration. This session is actually a sort of follow-on to an online webinar that I did earlier in the year around June timeframe. Did anybody see that? Good, okay, so I will, these slides are up on the SpringOne 2GX website. There's only 2 slides, so it's not that big a deal. We're mainly going to be looking at some code, specifically the application that I built in that webinar. I'm just going to go and review that and review some of the techniques that it provides to introspect and look inside your Spring Integration application. It is one of the samples. It's out on GitHub in the sample repository. And then beyond what we covered in the webinar, I'm going to look at actually using the JMX endpoint, where we can publish notifications, we can monitor attributes, we can invoke operations, and actually consume JMX notifications as well. So in actual fact, and what you'll see at the end of the session is that we can even use a Spring Integration app to monitor other applications, Spring Integration, Spring Batch, or whatever, any application that exposes JMX. You can write a sort of poor man's enterprise manager just using Spring Integration. So let's jump over to the code. The project in the samples repo is in the intermediate folder, and it's simply called monitoring. This application is based on a WAR template application that Spring STS provides. When we you can create new projects via a template, and a new Spring template project. We now have a number of excuse me, Spring Integration templates, some basic standalone applications, and there's this Spring Integration project which builds a WAR and gives you some starting point, and the application that it creates is actually doing a Twitter search, storing the tweets that are found from that search in basically in a map, and then has a web controller that presents those tweets to the user. Now in the webinar, I started with the basic application. I started adding different components to start exposing exploring what we can get with Spring Integration JMX. I'm not going to go through all that again. I'm just going to really just review what's there at the end state. If you actually go to, let's see, if we go to GitHub, let's see if the internet's going to, well, let me not worry about that. I did an initial commit, which was the starting point of the project, and then a second commit, which had all the changes that I made during the webinar. So you can actually, if you want to, you can work through that. But I'm just going to describe what we have in the application context. So let's explore. Well, first thing, let me just take a look at the integration graph. Graphical representation of what the application does. So, as you can see at the top left, I have a Twitter search inbound adapter. This is simply searching for hashtag, we scroll down, it's searching for hashtag Spring Integration. So the inbound adapter searches for that. It sends a message to a Twitter channel. We have a wiretap going on here. We'll talk about this. This dumping the tweets into a channel here, into a queue channel, was really just so that we can see the counts going up in JMX, and we'll look at that. The main component is it's got a header enricher. We add some headers. We have a transformer that does some transformation, and then we invoke this service activator that effectively holds these tweets, and then the web controller can then makes a call on that service to get the current state of the tweets. Now, this is supposed to be, it's an interactive demo, and we want to see some moving parts. Well, although we'd like to see more, it's not like we're getting a fire hose of tweets with hashtag Spring Integration. So what happens is we get the first 10 or so tweets, and then it just, nothing happens. So I also added this dummy inbound channel adapter that's just being polled, and we just creating a dummy tweet every 5 seconds, just so that we have some moving parts in the demonstration. Let's see. So what else? We have the header enricher transformer, and we dump them into service. We have a wiretap, and we're just logging the tweets. And then we also have, and we'll look at this a little bit later, this is beyond what was done in the webinar, is we're actually publishing the tweets as JMX notifications. And then finally, down at the bottom left here, we have a control bus, which is one of the mechanisms that we can use to actually manage our Spring Integration application, stopping, starting adapters, etc. As I said, you can check this project out at GitHub, and you can look at this graph in that case. Yes. Oh, where on GitHub? So let me see if the internet woke up yet. If you just go to the SpringSource account, github.com SpringSource, and it's Spring Integration Samples is the project. I don't know why I don't have internet. Let me see. Oh, here we go. Well, the Spring Integration Samples repo, the question was, what's the name of the project? The Spring Integration repo, the Spring Integration Samples repository has got 4 subfolders: Basic, Intermediate, Advanced, and Applications. This project called Monitoring is in the Intermediate folder. Let's see if I can... Here we go. So let's go back to the source of our application context now. So as I said, so we're starting off with this Twitter inbound adapter. I have this dummy adapter that is simply being polled every 5 seconds, and this dummy Twitter class just simply creates a dummy tweet. However, we have some stuff above this. People generally familiar with Spring JMX support? Okay. Spring, the core Spring has the notion, has very good support for exposing your beans or any beans actually as mbeans. It's much more flexible than the standard JMX mechanism. And the first thing we have to do is basically define an mbean server. This typically, by default, if the JVM already has a server, which it does since Java 5, it just hooks up to the existing mbean server. The context mbean export is this, again, that's not Spring Integration. It's just the standard Spring mbean exporter that will find any mbeans in your application context and make them available via JMX. The value add or the add-on from Spring Integration is under the int JMX namespace, which is our the JMX sub-project within Spring Integration. We have a second MBean export. This basically finds all the channels, all the message sources, all the message handlers in the application context and exposes them as MBeans. There are mechanisms where you can filter them if you don't want them all made available, but in essence, that MBean exporter is responsible to make those entities available via JMX, so we can do things like monitoring queue depths, monitoring message counts, monitoring the state of our elements. Now, the MBean exporter itself, it doesn't export itself to the MBean server. So in the case of this application, I've also done a standard Spring MBean export because the integration MBean exporter is itself defined as an MBean. So Spring, the standard Spring context MBean export finds that MBean and exposes it, and we'll see why we might want to do that in a minute, because it has its own capabilities, and it's useful to find that. So, well, with that said, let's fire up this application and see what we can see. So I'm going to just open up the web page here in the IDE and see what we got. So, as we can see, it simply has found these recent tweets that mention Spring Integration and presents them on the web page. So it's pretty simple application that's using Spring Integration. Now you'll also see these dummy tweets being interleaved, because every 5 seconds I'm creating this dummy tweet from the. So here we have some regular tweets that came from the inbound channel adapter, and then these from user, some user, are the dummy tweets that I mentioned that I'm exposing just to have some activity. So our application is running, and let's take a look. You can use your MBean viewer of choice, but I use mostly these days Visual VM. For those of you not familiar with Visual VM, it comes with JDK, and the first thing you have to make sure you have is you have to be sure to have enabled the MBean plugin. By default, the MBean plugin is not installed. You can see here I've installed one, and it's Visual VM MBeans. When you let me just shut this up. So you just go to this available plugins and you select the MBean plugin, and you OK the license agreement and all that good stuff, and install the MBean plugin. You then, after installing it, you will have to reconnect to any apps that you'd already connected to. But see, in this case, we found a Tomcat instance, and I'm going to open that instance. And once you've enabled the MBean plugin, you'll see an MBeans tag along with it. Obviously, there are other things in Visual VM. You can look at garbage collection and all that good stuff. But we're really interested in the MBeans at this point. Now, one thing you may have noticed in the application context is I added an attribute to the exporter's default domain Spring application. That's not necessary. The domain is really like the top level node in the MBean tree where you can find your MBeans. We use Spring Application because the Hyperic Enterprise Manager actually will automatically detect MBeans that are in that domain and make them available in the Hyperic console. Let's go back to Visual VM. So here we have this Spring Application domain. Can you, let's see if I can make that a little bigger. We have the Spring Application domain, and we can see now we've got a number of things have been exported. So the integration MBean exporter has made the channel, the handlers, the channels, handlers, and sources available here. And then we've got some other MBeans that I'll talk about in a minute. The Twitter service itself is exposed as an MBean. The integration MBean exporter, which is, as I said, that's exported by the addition of the context MBean exporter, and that gives us some additional information. So it has things like, attributes like number of active handlers, channel counts, channel names. We've got operations. We can actually get channel names on here and get a list of the channel names. But probably most interesting, at least to get started here, is to maybe look at some of these Spring integration elements. So we have a number of channels. So the inbound channel adapter is connected to Twitter channel. Twitter channel 2 is after the header enrichment, and then Twitter channel 3 is the final, is after the transformer. Now we can also take a look. You remember in the application context, I did dump the messages into this queue channel just because I wanted to expose or show you how you can monitor the queue, any channels that are queue channels. If we look at queue here, now we have a number of attributes, and we can see we've got some useful statistics here about the data in the queue. Things like, but perhaps more importantly here would be queue size. Obviously, if this queue size is accumulating, that might be something you'd want to monitor and identify that there's something wrong with the system because you're not consuming messages. So things like that. You can also, your enterprise manager could even look at things like, the send duration. How long is it taking these messages to be processed within here? And so we can use the attributes in that way. So that's one thing. So attributes, as I said, just by simply adding that one element, the integration MBean exporter provides all that information to you. Let's look back. So message handlers are outbound or anything that's consumers. So we have things like the add foo header header enricher, and they have a number of attributes as well. Is it active? We also have attributes on here, so you can actually operations where we can actually manage these components, start them, stop them, etc. And similarly on the message source, we have the Twitter adapter and we have the dummy adapter. And you can see here that I can, for example, I can just stop that dummy adapter, and we go back here, and now we're no longer getting those dummy tweets coming. So there's really two things you get out of the box by just adding that one line to your application context. You get visibility to attributes of what's going on inside of your application, and you also have the ability to control, and it's typically used to control inbound adapters because it's a way to sort of shut down your system in some kind of an orderly fashion, and we'll talk about that in a little bit more detail shortly too. Let me go back and restart that. And so now our tweets are, these dummy tweets are starting again. The next thing I wanted to show is this, there's a class called default Twitter service that is basically receiving these tweets and storing them in this Twitter messages map. Let me shut this. Just 1 second. Stop. And it also has so this is the class. When we get a new message that's put in here, we also have these start and stop methods, which is using the control bus, and I'll talk about that in a minute. That gives us the ability, a different mechanism to start and stop the adapters, and we simply when we get a new tweet, we're calling this add Twitter messages. Now you'll notice that I have annotated this class with @managed resource. So if you have your own classes that you're using, you're invoking either as transformers, service via a service activator, what have you, you can get access into your own classes using JMX by simply adding this managed resource annotation to the class, and let's see. And then I also manage this. I have a variable local total tweets, and I exposed on the setter. I exposed a getter for that attribute, and that's annotated with this managed metric. You can use managed attribute by default. Managed metric is a sort of a subclass of managed attribute, again used by Hyperic, and Hyperic can actually manage or detect these attributes automatically. So if we go back to Visual VM and just take a look at that, the application. Or the class is exported. You see here, it's default Twitter service. It's just default. It's with the class name. It's exposed with the class name. And again, that is automatically exposed just by having that context MBean exporter defined in the application context. And you can see here that we have this total tweets is made as an attribute. So it's very easy. Even if you, MBean and JMX definitions can get a little arcane, but with Spring, it's very easy. You just simply annotate it with managed resource, annotate your getters or setters with managed operation, managed attribute, managed metric, what have you, and then it's automatically exposed, and you have visibility to that. Yes? Right. The reason for that, the question was, do we need both annotations? They really serve two different purposes. One is managed resource says to Spring, declare this as an MBean, or register this class, or register an MBean for this class with the MBean server. The managed metric or managed attribute or managed operation annotation is to say, I want this specific piece of data within this class to be exposed via JMX. If you don't do that, and in fact, there are a couple of different ways you can define. There's also an XML declarative way you can expose MBeans with Spring, and by default, that will expose every attribute and every operation on a class. In this case, we really want to limit, or in most cases, you don't want to expose every method as an operation. You really just want to limit that. So that's what that second annotation is used for. So we have that. Now the next thing I want to show is the integration MBean exporter itself. As we saw a few minutes ago, it does have a number of attributes and a number of operations that are useful. A new feature that was made available in let me see here. I've got to, it's in let's see, where is it? This is a new 2.2 feature, and this has been asked for a lot with Spring integration, is the ability to perform an orderly shutdown of your Spring integration application. Typically, particularly if you've got in-flight messages, if you just stop the application context, it's sort of a hard stop, right? So we start unsubscribing channels, we start tearing down the application context. Any in-flight messages are probably going to have some errors. So this operation now on the integration MBean exporter is an ability to do an orderly close down of your Spring integration application. It starts out by stopping task schedulers, so pollers are stopped, but they're not stopped hard. It's just basically if you've got something in process, just don't schedule any new tasks. Once we've shut down the task schedulers, we shut down task executors. We then stop all the message sources, and then we if anything failed to stop, then we might do a hard stop. But there's two properties or two arguments that are passed into that method, or whether we're doing a hard shutdown or a soft shutdown, forced shutdown or not, and then an amount of time. We haven't really tried to do any assessment of when the messages really have quiesced, when we've really, when all the messages have stopped. We simply allow you to specify a period of time. So you might say, stop my application context, and let's wait for 30 seconds. Now, if most of your messages get processed in that time, then that's what happens. But it gives you that ability to say, stop any new messages coming in, let any existing messages flow through, and then wait for some period of time for that to happen, and then return, and then you can shut down your application context. So programmatically, you would get a reference to the MBean exporter and just call this method, and when it returns, you can then close your application context. Or you can invoke it via control bus, which is what I'll show you in a few minutes. So that was a very often asked for feature on the forums. How do I know when I don't have any in-flight messages? One of the things that we do, so certain components we can actually, it's actually a problem. So consider a TCP inbound gateway. You know, we've got a socket. We're receiving messages coming in through TCP. We're sending those messages into the integration application, and now we want to shut it down. In the old world, if we just stop that TCP adapter, it would close the socket, right? So that would stop any new messages coming in, but it won't. When any responses to in-flight messages would fail because we wouldn't be able to write them out. So what we do with adapters like the TCP adapter, the HTTP adapter, is effectively say, we're not going to accept any new messages. We keep the socket open, but if we get a new message in, we'll reject it. In case of TCP, it's a little difficult because there's no standard way, but like with HTTP, we'll just say, I don't remember the result we send back, but it's a 4.0 something, which basically service is unavailable. So at least the service is still running. Any in-flight messages are completed, and we can shut down. Yes. So the question is there any way to, can we not just stop the channels? Well, the channels are really passive components. They're not really active. There's nothing to start or stop. Messages are placed in channels and messages are consumed from channels. This is an attempt to do it in an orderly manner, so that we do stuff in the right sequence. If, for example, we stop in this case we have a service activator. If we stop that service activator, the first thing that happens is it unsubscribes from the channel, right? So it says, okay, I'm no longer going to receive messages from the channel. Well, if we still have a message that we just received at that time, it would get placed on that channel, and then we'd get a dispatcher has no subscribers message or exception, because there's nobody listening on that channel. So that's why we had to come up with this sort of fairly laborious algorithm to stop things in the right sequence, so that we can allow for any in-flight messages to complete, and but not allow any new messages to come in. And once you've one caveat here is, once you've run this method, you can't restart. There's no okay, I'm going to open it up again. It's a sort of, it's really something you would execute right before you want to shut down your application, but you want to shut it down in an orderly manner. There's another question over here.
So if you shut down the task managers or task executors first,
Mm-hmm.
and you've got a simple architecture, say, inbound adapter, a channel with a queue, transformer, and that queue has messages in it, is that queue going to empty before everything gets shut down if task executors are shut down first?
Good question. No, that would be a hole in the current mechanism, because if you're using a polar midstream, we'd stop the scheduler. So we'd stop the scheduling of pulling messages from that. So yes, that's a good point. But most applications don't do that async handoff in the middle of a flow. Like, you've got a polar that's polling for a file system, bringing things in, and for the most part, it's direct channels. But that's a good point. We'll have to give that some consideration in the next go around.
Because honestly, my application has that, and that's very much a concern.
Yeah. Now, what you can do, we have to take that offline. I don't know if I repeated the question, but it was, what if you've got stuff in a queue channel when you shut down the task schedulers, and that those messages would remain. So we would have to. But yeah, I'd like to. This is the sort of first go around. We did work with a number of users on refining this process, and obviously we didn't get all the requirements, but it was really a first attempt at doing this, and any additional improvements we can make, would definitely welcome that feedback. So how are we doing? So. Yes. So so now we've exposed the messaging infrastructure. We've exposed the any MBeans that you need or you want to have, that where you can add monitoring capability. And now we've looked at the integration MBean exporter, which gives us this orderly shutdown. The next thing I just want to touch on is the control bus. Anybody using control bus in their application? Oh, good number of you. So control bus is a mechanism by which we can actually send messages to components within our Spring application. In this case, we simply have a control bus channel connected to a control bus. And the control bus is responsible for taking action. So let's take a quick look inside the default Twitter service to see which control bus messages have. So we're exposing a stop Twitter adapter. And this is actually another common use case where people actually want from the web to be able to, from a web application, to be able to start and stop adapters. So in this case, we're using a spell expression. So at Twitter, this is a reference to a bean called Twitter, and we're going to invoke the stop method on it. Now, because I've got this dummy Twitter in here, I decided to add code to basically, when we stop the adapter, to stop both the the regular Twitter adapter and the dummy Twitter adapter. And similarly, we've got a start Twitter adapter, which does the same thing. It's just invoking. So you can reference any method on any bean. So it's not just Spring integration components. If you've got a bean and you define it with some ID, you can invoke arbitrary methods on your classes using these constructs. The web page has got a couple of buttons on it. So here we've got this start Twitter search, stop Twitter search, and it just basically is invoking those services. And so, yeah, so we stop the Twitter adapter. Oh, I'm not injecting that. So, and then we can start it again. And I've also exposed this shutdown flow in that Twitter service as well. So if I look at the shutdown, this is basically just saying it's using spell and invoking the integration MBean exporter. Stop active components. It's not a forced shutdown, and we're going to wait for 20 seconds for it to stop. And all we have to do is to send a message to the control bus channel to make that happen. So let's go back to our web page and shut down the integration flow. Now, you see here, you can see the steps. So it stops the task scheduler. I don't know. I should have run this. It's been a while since I ran. Okay. So now it's stopped the message source, it's stopped the dummy adapter, and now it's all shut down, and we can restart our application. Like I said, there's no way to get back from this. It's sort of really a final step before we shut down. Because there's things that have been shut down that really isn't convenient to start up again. So I'm going to restart the application. Oh. Any more questions on this while we're waiting for the... Yes, sir. So the question is can you expose MBeans without polluting them with Spring annotations, right? Yes, there is, and that's all covered in the JMX section of the Spring reference, not Spring integration. There's an XML declarative way of saying I want to have an MBean exporter, and you can give it class names, you can give it method names on classes to say exactly what. You can define there's a reflection method that'll simply you give it the packages, and it'll find every class in there and expose every method on every class by default. Or you can do it. You can limit it to individual methods. And the question is will it do the same thing as managed resource? Yes, and that's not Spring integration. Managed resource is a core Spring annotation, but it works exactly the same. It's just the annotation. I just find I'm not a big fan of annotations in general, but in this case it makes it very easy to expose a class as an MBean. But yes, you can do it quite easily using declarative exporting with XML. Yeah, well, this. That's a function of the wrapper. Right. I mean, that start active component, stop active component. That's our MBean. That's not. That's a Spring integration. The IMBE integration MBean exporter. That is a managed resource, and it will be exposed if you have a context. So that particular operation is exposed that way. If you've got your own class that's got some active components in it, and you want to expose a method on that, then you could do that using XML declarative exporting. The question is, can you filter on the methods? And yes, it's very, very flexible in terms of exactly what gets exported. By default, if you export a class, all the methods are exported as operations and attributes. Like it finds getters and setters. If there's a getter and no setter, then that's a read-only attribute. If it finds a getter and a setter, that's a read-write attribute. But you can, in the XML, when you define the mbeans that you want to export, you can give it a list of method names or patterns to say exactly what you want to expose. The control bus, yeah, anything that's exposed as an mbean is available through the control bus. Yeah. Performance costs. There's not really any. The Spring integration, Spring integration components, the way that they are exposed as mbeans is by wrapping them in a proxy. So there is a method call overhead. There's a second method call because the way we have to maintain those statistics, right? The counts. That's done via effectively wrapping the channel, wrapping the message source. So there is a small, but in modern JVMs, it's not at all expensive. Another question, sorry. Not dynamically, no. You can put that mbean exporter in a Spring profile, so you can say, okay, I want to run with JMX or I want to run without. But it's not a runtime switch that you can turn on and turn off. We either expose the mbeans because we find that element, or we don't. But as I said, the overhead is minimal. So let's take a look at if there are no more questions at this point. And I want to switch directions a little bit and now talk. So that's really about what I've talked about so far is really nothing more than standard Spring JMX exporting classes, making the operations available to JMX. Yeah, we got the control bus, which gives us another way in. You know, we don't have to use Visual VM or an enterprise manager to manipulate our mbeans. But Spring integration itself has a number of JMX adapters. So the first one that we'll see, if we look at my context here, I added you see here at the end, this is not in the webinar from June, but I added this JMX notification publishing channel adapter. Now, for the purposes of this demo, I'm actually publishing the tweets as a JMX notification. Typically, you wouldn't do that. JMX notifications are typically some kind of an alert. So if you have some condition, maybe you've got an error channel on an inbound gateway or something, and you detect an error, a lot of people would log it. Maybe an error, with an error level, but you could also send that exception as a JMX notification using the JMX notification publishing channel adapter. Just tap the error channel on the inbound adapter and send the result to this JMX notification publishing channel adapter. Like I said, for the purpose of what we're doing here is I'm just simply every tweet that comes in, I'm publishing it to JMX. And what does that actually mean, or what does that look like? Now, of course, I just restarted my Tomcat, so I've got to reconnect. The first thing that we'll see is let me go back to the class. So I called it. I'm sorry. So it's a notification publishing channel adapter, and it's actually here as an mbean, and you notice in previous cases I looked at attributes and operations. This time we're looking at notifications. So I'm going to subscribe to notifications that this mbean emits, and now you can see we're seeing the actual contents of our tweets are now showing up in Visual VM in the MBean tab. So these are simple. It's a simple way to, and many enterprise management apps understand how to retrieve JMX notifications. So this is a very easy technique you can use to send an alert to your ops people that something's gone wrong with your application. You can build these JMX notification publishing adapters into your application, and these the notifications will be sent to the enterprise manager. So that's kind of cool, interesting way to look at things. But let's sort of take the next step and say, what could we actually do with Spring integration to act as that, or act as a sort of poor man's enterprise manager? So this application is using a JMX notification publishing channel adapter. And I have another application that is able to consume those notifications. Now, one of the features that may not be obvious to everybody without digging into some of the Spring documentation is, as well as we had in here, we had our MBean server. I just use context MBean server, which is basically saying, hook me into the local MBean server that's running inside of my JVM. We can connect to a MBean server using Spring that's in a different JVM. So in this case, my TC server instance here is actually configured, as well as me being able to connect to it locally via its PID here in Visual VM. It's also out there listening on port 6969. It has security set up so that not everybody can get in, and of course, I provided those credentials here in this environment. But via this MBean server connection factory bean, I can create an MBean server in this application context that's really a proxy for a remote MBean server. So when I run this application, you'll see now I have a notification listening channel adapter. This is going to consume, and see here we have a object name. Now, everything in MBean world is an object name. So if I go to this tweet, there's a metadata tab here. You see it has an object name. The domain is Spring application, type is tweet publisher, name is equal to tweeter. Now with Spring integration 2.1 and before, I think these adapters were first introduced in 2.0. But in 2.1 and before, you had to have one notification listening adapter for each MBean. So the object name that we defined in this definition. So here we've got Spring application, type equals tweet publisher. I've now given it a wildcard. I'm saying this notification listener can receive notifications from any MBean that's got an object name that matches this pattern. That's a 2.2 feature. So this application, its MBean server is a proxy to a remote MBean server via this MBean server connection factory bean, and the notification listening channel adapter is going to receive those notifications. Before I do that, let me just comment out. Let's see. Let me just comment this one out. So let me run this application because I don't have it in my recent list. So this notification listener is simply a main. Oops. It's a main class that's loading up this application context. It takes some commands which we'll look at in a minute. So let me run. Do I have it? No. So now our listener is receiving these notifications. You see here, and it has type equals tweet, which was the type that I put in there, and it's actually got the data in the message. So now we have a Spring integration application that's consuming notifications from another Spring integration application. It doesn't have to be another Spring integration application. Any application that exposes JMX notifications you could actually consume them in a Spring integration app and take some action based on those notifications. The second element that I had in here is, let me go back to the one that I just commented out, and I'll uncomment in it. The second component that I'm going to share with you is an attribute polling channel adapter. So this is saying, okay, I'm going to connect to this MBean. Well, the client connector is the name of my MBean server again. So that this is the remote MBean server, the Tomcat, the TC server instance that we're using. And this time we're going to monitor this send count attribute on the Twitter channel MBean. So let's just go look at that. The message channel, Twitter channel attribute currently has a send count of 129. So what the application is going to do now, in addition to receiving notifications, is that, and I've got this running on a poller with a fixed delay of 12 seconds, so every 12 seconds he's going to poll this attribute. So again, you could use this to monitor some attributes. You could write a monitoring application that's going to monitor attributes. And if an attribute goes out of range, you might have a counter that goes out of range, and it would, you can then again take some action based on that. So we see we're getting notifications every 5 seconds, because that dummy adapter is creating a tweet every 5 seconds. And then every 12 seconds, we're actually pulling out the current state of that attribute on that MBean. And of course, it doesn't have to be an integration component. You can be monitoring your own components, your own attributes on that. And then finally, we have another Spring integration component called an operation invoking channel adapter. Remember, I showed you those operations in Visual VM where you can start and stop adapters. Well, I've defined 2 operation invoking channel adapters that start and stop that dummy adapter. So again, using the remote client connector, in this case the stop operation, and here we're just referencing the object name of the dummy adapter. And these are just 2 different ones. One's to invoke the stop method, one's to invoke the start method. If we go back up a little bit, I have a gateway. So let me just go to the notification listener. What I've got this little, it's just reading standard in, and if it gets a Y, it means start the adapter. If it gets a no, stop the adapter. We simply invoke, see we're here so we're sitting on system in read, ignoring new lines, and then we just send the value that was read from system in to this gateway, and the gateway is a standard Spring integration gateway where it's a void returning operation that's going to send this command. So if we go back to the context, the gateway is this child class, or sort of the inner class of the notification listener called gateway, and it's going to send its message to the command router, and the command router is a simple expression-based router that's saying route on the payload, and if the payload contains the value Y, then send it to the dummy starter operation invoking adapter. If the value is no, send it to the stop. So if we go back to the console, this application is now receiving messages, and I can just I can do no or N, and that will stop the inbound adapter on the other application. I'm going to go and switch to. Well, let me do it here. Switch to TC server, and you see here we got stopped dummy adapter. So now we have one Spring integration application that stopped an adapter on another one. So again, you can see how you can build up this. Of course, if we go back to the other window here, the attribute polling adapter is still polling, but of course the number's not incrementing anymore because we stopped the adapter. So you can see that you can build up a fairly sophisticated Spring integration application that can manage your other Spring integration applications. So if I start it again, it's now restarted the adapter. I'm going to turn off page switching, and once again now we're receiving notifications, and indeed the attribute send count is incrementing once again. Any questions on the Spring channel adapters and with JMX support? So the four that we have, or the four that we have are notification sending channel adapters, notification listening channel adapters, attribute polling channel adapters, and operation invoking channel adapters. Yes, sir. You don't? Oh, I think it's still in a branch. I think I didn't commit it yet. Yeah. I'm sorry. The question was these most recent changes to the sample don't seem to be in the GitHub repo, and I think it's probably because I just haven't pushed them from my topic branch. Let me just verify that. I'm pretty sure they're in a recent branch. Let's see. But I will have this. Yeah. So they're in my branch, but I will after this meeting I'll commit these and push them. I'll make a pull request. There might be an open pull request. I'm not sure. So that pretty much concludes the JMX part of this discussion. We've covered the ability to expose JMX attributes and operations on integration components by using the integration MBean exporter. We've shown how to export the integration MBean exporter itself and any other MBeans using the standard Spring MBean exporter. We've looked at being able to connect to a remote MBean server using the MBean server factory bean, and we've also looked at the 4 JMX adapters that Spring integration provides, and of course the control bus too. The last thing I want to show now is the Spring Insight support. Is anybody using Spring Insight or familiar with Spring Insight? Oh, good number. So, some time ago, we wrote a plugin for Spring Insight to support Spring integration. For those not familiar with Spring Insight, and we'll see it in a minute, previously it was great at being able to analyze web activity. So you'd get requests and posts, and you could see where the performance of those operations was perhaps needed some evaluation. The Spring integration plugin for Insight basically does the same thing for Spring components. So anything that is asynchronous from a Spring perspective. So we have inbound adapters, inbound gateways and such. They can launch a message, and we can actually see in Spring Insight where the time is being consumed in this particular application. So, and since, let me stop this because I need to. With recent versions of STS, the Spring integration plugin is now actually bundled with the TC server instance that is bundled with STS. This is, I think I have on this machine, I'm running 2.9. It's in 3. It's certainly been since 2.9. May even have been earlier than that. But you see here that we have the Spring integration Insight plugin is now available out of the box. Now I understand that Insight is also available on other components or other servers now. It's not just a TC server feature. You can run it in Tomcat and I believe WebLogic at least. I don't know about other app servers, but so I usually run with Insight turned off unless I need it because TC server starts up quicker without it. So in order to enable Insight, we have to check this enable gathering of metrics. So this is going to take a few seconds to start up. So Spring Insight basically is a mechanism to capture performance statistics about your application. So it's previously, or originally, it was implemented as a developer tool. So you can actually, so developers can see potential bottlenecks in their code before it got into production, right? So, but obviously, production and even test environments are what happened here. Environments are different, so now it's actually available in enterprise versions as well. So you can actually run it in that. Yes.
Is that the Spring Insight can we use for any non-Spring application for see the performance stat, or it has to be a Spring?
No. Well, I mean it's relying on the Spring infrastructure to actually measure the performance. So we've got our application. If I go back to the web view and do a couple of refreshes and stuff here, so we actually have some web activity. Let me go over to Insight itself. Localhost Insight. So this is the Insight console. Obviously our application is called monitoring, and often we get obviously web things. So here we've got the home controller home, and as you can see, if we scroll down to here, we can actually, this is, again, for those of you familiar with Insight, you can see that we did a get on this URI, and here we can see that there was 45 milliseconds were taken in web dispatch and such. So that's the standard Insight, but the Spring integration plugin now, depending on the adapter type, it'll either start with the adapter or it'll start with the first channel. In this case, the Twitter channel is the starting point of our application. we can see that this is in red, so this is kind of it's a frustrated application in Insight terms. But I did that on purpose because I wanted to evaluate where the issues are. So this publish subscribe channel called, and the name of the channel is after the pound sign here, and we can drill down into these components, and you can see here that they're taking some significant time. So here's one that took 3 seconds. So let's take a look at where this time is being spent, and let's zoom this in a little bit. So we can see what Insight is giving us is a tree. A full stack explosion of where the work is being done. So you see here, I remember I had off the original Twitter channel, I had a wiretap, so we can see this logging activity, and then I bridged it to a Q channel. They were just noise in terms of the overhead they were taking. We then sent the message to this add foo header enricher, and then we got this. We seem to have some period of time. This 1 second is being spent in this no op but slow transformer, which I'll show you that in a minute. Basically, it's got a 1 second delay in the transformer, just to show how you might go back and look and say, why is this component taking so long? If any of these things were doing JDBC, you'd be able to drill down and actually look at the full select statement, exactly what the query was. And where we went. But as you can see here, then finally this default Twitter service, that for some reason took 2 seconds. So what the heck's going on? So if we go back to the application, let me zoom out. The first thing we saw was that default Twitter service was taking 2 seconds. Well, it shouldn't be too much of a surprise. I've got in here, if it's one of those dummy tweets, then I'd put this arbitrary 2 second delay in here. In the case of the 1 second in the where is it? Oh, Spring integration context. In the no op but slow transformer, you'll see that's actually just a little groovy script transformer that's got this 1 second, arbitrary 1 second delay in it. So that was where we found our 3 seconds that was spent in there. So hopefully it's a very quick overview, but it gives you an insight into what your application's doing and the ability to detect and remediate performance problems, not only in web apps now, but also in Spring integration applications. Does Insight have overheads? Yes, there is a little bit. So again, I suppose you could say every little bit adds up, but yes, we capture when a message goes in. What happens is the channels are advised, and so we capture the frame and the timestamp. So every time you go through an integration component, we capture the time and the actual frame. So then the analysis is, most of the analysis, it's very, very lightweight though. The capture is very lightweight. Most of the analysis is done at runtime in the UI in terms of finding where the issues are. And of course you can, it's something you can turn on and off at the console. It's not like, so you could if you detect that there's a problem in your application, if your server is configured with Insight, but Insight turned off, and you detect you're having a problem, you could always then turn that on, restart the server, and just capture for some short period of time to get the statistics. And the question there was, is there any overhead with using Insight? Well, if there are no other questions, we do have one, yes. If you turn it off, yes, the history is maintained. So the question was, if you turn off capturing, do you lose the history? No. What happened, the way Insight works is there's effectively an agent, particularly in a production environment, there's an agent that runs on the server that sends these trace frames to an admin that then maintains that data. This is also built into the vFabric App Insight product as well. So if you're in the vFabric space and you're using App Insight, then these frames are available in there too. But no, you don't lose the stuff if you disable. Yes, sir.
It's more a general SI question. In the beginning, you showed us a JMX op to get the channel names.
Yes.
Is there a way to do that through the API without loading the application context and going through and getting all the channels?
The question is there a way, it's more of a generic SI question, is there a way to get a list of channels in an application context without loading up the application context?
Is there a way through the SI API, like a get channel names method? How is that data showing in the JMX op?
Oh, okay. The question is, how does the MBean exporter know about all the channels? Well, yes, the MBean exporter is a Spring Bean, and it's a Bean Factory aware Spring Bean. So that when the MBean exporter initializes, it goes and gets all beans of type message channel, right? So it inherently it keeps a list of those channels in its local memory. So that's how it does that. Interestingly enough, I don't have time to show it now, but I worked on when we were working with one customer on a channel coverage. People are familiar with code coverage tools, right? Emma and such. Question came up, okay, I've got this application with 15 channels in it. Do I have adequate test coverage in my application, in my unit test suite? And so what we did was we actually made all the test classes were subclasses of a superclass, and the superclass did just that. It got all the channels, it programmatically added an interceptor to all the channels, and then maintained state. So then when we ran the unit test, we wrote that data out to a file, and then Sonar picked that up, and we had a Sonar plugin that said, oh, you've only got 40% channel coverage on your channels.
Actually, for unit tests, I want a trace route, basically generate a trace route to make sure I...
Well, that's an interest. That is something that I forgot to mention. So there is also I didn't point it out in the application context. We do also have message history. So enabling, and just by adding this element here, when a message gets to the end, you'll be able to step through. You see in the message history every component that message touched between the start and this point. Excuse me? That does have overhead, yes. Yes, yeah. So again, that's probably not something that you'd want to do in production, but certainly in the test profile, if you're using Spring Profiles from Spring 3.1, enable message history in your test profile, and then maybe even do some analysis. A lot of people for testing, so if you've got, let's say, an HTTP inbound adapter and a web service outbound adapter, a lot of cases people will write the tests that basically they send a message into the input channel and then capture the output channel. So basically you're testing the flow except for those edge components. So in that case, where maybe you convert the last channel to a queue channel, so then just in your test case you do a receive against it, you could receive that message and then examine the message history to make sure it went through every component that you expected it to go through.
Question. So that message history, where we can capture all the message from the trace log?
So the question is, what does message history do? It just adds a header. It adds a header to the message called message history, and every time it goes through another component, that message history is augmented. Yes, it's a sort of a header. Yeah, it's not adding a new header. It's enriching an individual header each time. True, true. The question is, you know, if I'm using Spring integration in the so recommended fashion, i.e. code to POJOs whenever possible and don't expose your application to the messaging infrastructure, then of course you won't have access to the messaging infrastructure, you won't have access to the headers. But we're talking about test cases here, not production code, where you could write a test. In that case, yes, you would have to pull a message out of a channel and examine the history. Any more questions? Yes, sir. Yes. Well, yes, it's a little tricky because it uses RMI to do the connections. So there are some. If you Google it, you'll find there are issues with RMI in terms of the permissions and host names and stuff. But yes, you can do that. You can run it. You can connect it, but there's certain firewall requirements. You know, it's not just one port. It connects to the RMI server and then it passes back another port. So it can be tricky, but yes, you can do it. What I do most of the time though is just run it over X Windows. So I can, you know, I'll just SSH in, enable X, and then just run Visual VM on the remote machine, but export the console back here. Yes, sir. Question is just in SI is can you peek at the contents of a channel, you know, read it without actually consuming it? And no, that's not currently, but it's not available with the standard channel. There's nothing stopping you writing your own implementation of the message channel that would support that. A number of techniques been used to use, for example, a global interceptor. That we have a notion of a global interceptor where you give it a pattern, and so normally interceptors are defined at the channel level, and you can intercept messages, and there's like pre-send, post-send, etc. You can define a global interceptor with a set of patterns and say these are the channels I'm interested in, and then do any additional logic that you want to do. And that's really exactly what that's mentioned for. And that's what I did in this test case, was I basically dynamically added an interceptor to each channel and then captured some state to say how many messages were actually processed by this channel in this test suite. So yes. Right. And you can. The question is again, do we, if we want to capture times and performance and stuff, then that would be a good place. And in fact, one question that came up on the forum some time ago was, what if, like, if you've got a standard, like these statistics are just going to give you average send time for all messages of all types. What if I have I have different payload types that go through my application? Well, we in this, again, this monitoring test case, it's not a full implementation. It was something I threw together as part of this webinar, and it's this notion of a payload aware timing interceptor that basically creates a stopwatch on the pre-send method, and it holds a set of statistics based on the object type. So we end up with this stats map, which is I can't. Oh, okay. So am I zoomed? Oh no, that's it. Why can't I? Well, so in the pre-send, we start a watch, we start the stopwatch. Stopwatch is just a Spring timing component. So we start the stopwatch. I hold it by the class name. So I've got a class name. Do the pre-send, and then on the post-send, stop the stopwatch, get the time, and then get the type, and basically keep a an average response time based on the message type. As I said, this was not, I wouldn't say this is production level yet, but it was something that it was really as a starting point for somebody that specifically asked the question, how do I get statistics based on a payload type rather than just on all messages going through the channel? So that's something you can play with in this sample app. Standard closing thing. I did mention so that the webinar, if you, like I said, you probably won't get much value going through the webinar now because it really was a sort of a summary of getting from a starting point to what we saw as the end point of that application. But it is there, and of course the usual suspects. But I'll still be here for a while if anybody has any additional questions. Okay, thanks.